Assalamualaikum warahmatullahi wabarakatuh. My name is Fathin Zulaikha Binti Hishamuddin, and today I will be explaining Module 3, Spatial and Geostatistical Analysis. There are three parts of this module, which are Spatial Analysis, Geostatistical Analysis, and Geostatistical Analysis.
For Module 3, first of all, drag derived shapefiles to Table of Content. After that, choose Art Toolbox and choose Buffer under Proximity. The input features, you have to choose Derive Shapefiles from your folder. After that, click OK. For the linear unit, insert 300 and the dissolve type, choose to All. After that, rename your output feature class as Buffer underscore Fathin underscore 300 all. After that, click OK. Now, wait for the buffer process to finish. Now the buffer is completed, and if we zoom, this is the form of dissolve to all. After that, repeat the same process. Click on buffer under proximity. After that, the input class is derived same as before. And click OK. The output feature class, choose buffer underscore Fathin underscore 300 known. The linear unit is the same, which is 300. Then the dissolve type is known. After that, click OK. Now again, we wait for the buffer process to complete. When the buffer process has completed, this is the form of dissolve to known types. Now click on overlay and click erase. After that, the output, choose derive, and the input, choose the Fathin underscore 300 all, and name the layer as erase. After that, click OK. Now we wait for the erase process to complete. Now the erase have been added. If we zoom in, this is the form of overlay erase. Now click on overlay and click on union. After that, for the input, we add district Kelantan and buffer 300 all Fathin. For the output, we name the output as union underscore Fathin. After that, we click OK. Now we wait for the union process to be completed. This is the completed form of union features. Next, we click on intersect, and for the input features, we choose derive and we choose district Kelantan. For the output, we name our feature data as intersect. After that, we click OK. Now we wait for the intersect process to be completed. Once the intersect process have been completed, this is the shape, the form of intersect features. If we click zoom to layer, this is the final look of buffer and overlay features. Now we can save our project for the second part of module 3. For the next part of module 3, choose new map. After that, drag daerah to the table of content. After that, choose Art Toolbox and click on Conversion Tools and choose Add Cell and choose Add Cell to Table. For the input features, choose Data Ground File and click OK. Once the data ground has appeared on the table of content, right-click at the data ground and choose Display XY Data. Choose the X point to E and click OK. Right-click at the Excel data again and choose Data and choose Export Data. Rename the output data as the date you did this project. Rename it as 23rd of May 2022. After that, click Save and click OK. Now, the new layer has been added. Next, click on Customize and click Extension and activate the Geostatistical Analysis tool. After that, click Close. After that, go to Customize and choose Toolbar and turn on the Geostatistical Analysis and choose Geostatistical Wizard. After that, choose IDW and change the data field to PM10. Click Next and click Finish. Now click OK. This is the result. After that, right-click on Layer and choose Properties. After that, choose Other. Click Specific. Click Outline. After that, choose Daerah. After that, click OK. Next, choose Clip to Shape. Choose Outline again and choose Daerah. After that, click OK again. This is the result. After that, right-click on IDW, choose Properties and choose the rectangular extent and click OK. And this is the final look for our module 3. This is one of the interpolation process. After that, save our project as module 3 underscore geostatistical analysis and click Save. That's all from me for module 3. Thank you.
First practical highlight question. Discuss how do the results differ between dissolve all and dissolve none in buffering. When will this be important? After inspecting, remove the not dissolve layer. Dissolve all the buffer together into a single feature and remove any overlap. while the soft node is an individual buffer for each feature is maintained regardless of overlap. This is by the default. The dissolve process in buffering would be important to determine the area covered within a specific location. Practical highlight questions number 2. Screen captures each overlay analysis done and explains the overlay feature. Erase. Erase is used to erase polygons, lines or points from the input features. A line erase feature can be used to erase lines or points from the input feature, while a point erase feature can be used to erase points from the input features. Union. Union computes a geometric union of the input features. All features and their attributes will be written to the output feature class. And lastly, intersect. Intersect computes a geometric intersection of the input features. Features or portions of features that overlap in all layers of features classes will be written to the output feature class. Practical highlight question number 3. How is the XY tolerance defined in the intersect dialog? How many records does final SHP have? The answer is by using the geoprocessing tools. The XY tolerance to be set on the geodata sets created by geoprocessing tools. By default, a tool that uses this environment will use the input feature class partial reference XY tolerance. The final SHP has 3 records, which are derived SHP, derived buffer Fathin _300 all, and district Kelantan SHP. Practical highlight question number 4. Highlight all spatial analysis performed in this practical and relates the function of each analysis with real application in environmental context. The definition of spatial analysis is the process of examining the locations, attributes and relationships of features in spatial data through overlay and other analytical techniques in order to address a question or gain useful knowledge. The first real application in environmental context is by using the intersect tool. The function is to determine area with higher water reservoir by overlaying of more than 2 layers, including rebuilding topology of the merge points, lines and polygons, and operations on the merge attributes for suitability study, risk management and potential evaluation. Second, by using buffer can reclassify stream distance by sourcing layers composed of continuous values such as slope and distance layers are first reclassified into meaningful range of values. First, geostatistical analysis practical highlight question. You have tried several types of interpolation method. Screen capture the output and explain, based on your observation, the difference between all methods. First interpolation method found is inverse distance weighting, and second is linear regression. The difference between these two are inverse distance weighting use data field and weight field as their inputs, and the results is the interpolation color, while for linear regression they have 2 variables, which are the predicted and the measured PM10 concentration. Second, geostatistical practical highlight question. Summarize the use of geostatistical analysis used in this practical in environmental study. The definition of geostatistical analysis is a class of statistics used to analyze and predict the values associated with spatial or spatiotemporal phenomena. The answer is The geostatistical analysis used is the inverse distance weighing. The function is used to estimate pollutants levels in order to decide if they pose a threat to human or environment. While in soil science, it is used to map soil nutrients levels such as phosphorus, nitrogen, potassium, and etc. And finally, to study their relationships to crop yield and subscribe precious amounts of fertilizer for each location in the field.